Question 7, first of the long ones. Fiona is driving on a motorway. V of t represents her speed at any particular time, and the time we're looking at here is between 0 and 5 minutes after passing point A on the motorway. Work out her speed when she passes A, so time is equal to 0. Therefore, V of 0 is equal to just the constant 109 kilometers an hour. Work out her acceleration. Well, velocity speed is equal to u plus at. If you haven't come across these formulas, you probably should have. So velocity differentiated with respect to time is acceleration. So we have v of t, so dv dt is equal to 3 by 2/3, which is just going to be 2t squared minus 2 by 6, 12t plus 13 is equal to 0, and at t is equal to 5, dv dt is equal to 2 by 5 squared minus 12 by 5 plus 13. So 50 minus 60 plus 13 is 3 kilometers an hour per minute. So find the value of t at which it reaches max speed. So max, we imagine this is a cubic. Let's just do a little sketch here. This is the cubic, starts low, ends high due to the positive x cubed. And it looks like it comes up here, passes at 109, comes back down and goes on in that direction. Let's see the reason why it looks like this. So we're looking for our turning points, our max and min speeds. So if we look at dv dt, we solve that. So the slope will be equal to 0, 2t squared minus 12t plus 13 is equal to 0, and this definitely doesn't factorize, so the minus b formula. Write it into your copies. We're going to get square root of 40. It looks like minus 12 plus or minus the square root of 40. 144 minus 8/13 is 104. It's definitely square root of 40 over 2/8. This gives me two answers. 1.42 and 4.58. And this will be time in seconds. So her max, change color, her max speed looks like it's after 1.42 seconds, and then her min speed looks like it's after 4.58 seconds here and here. What are we asked for? She reaches her max speed during the first 4 minutes, so it can't be the 4, so it has to be the 1.42. Correct 2 decimal places. Now you would be expecting a question like this to just have some idea of what this looks like, starts low, ends high, but I just put t in. Why are they only giving us between 0 and 5? Well, if we put t is equal to 10, we're going to get 2/3 of 1,000, that's 667, minus 600. Then we're going to get plus 130, I'll write it here, and plus 109. So we're going to get 67 plus 239, 239. And 67, which looks like it's 306. Now she's not going to be going 306 kilometers an hour, so I just did a couple of these things at the start, but that's what it would be up here in the graph, which is why they're limiting the kind of range of this graph between two values, 0 and 5. So if the turning point's at 4.58, this graph is kind of stopping at that point there at 5. So we're only looking at a section of it between 0 and 5. So let's have a look at the next part. We're asked to use integration to find average speed. So let's have a look at t again. 2/3 t cubed minus 6t squared plus 13t plus 109. And if we integrate this, we're going to get 3 by, we're going to get actually to the power 4, increasing the power, so I'll just do it long form, 2t to the power 4 over 3 times 4, minus 6t cubed over 3, plus 13t squared, plus over 2, plus 109t. So it's going to be t to the power 4 over 6, minus 2t cubed, plus 6.5t squared if you so wish, plus 109t, and we have to integrate this for the first 5 minutes, so between 5 and 0. Should put down here the integral of that, and then is equal to the line below. So if we put 5 to the power 4 over 6, it is the average speed, isn't it? Integration average speed, so it's 1 over a, or 1 over b minus a. So we're going to get a fifth of it. Just be careful. 5 to the power 4 over 6, fifth of all this, minus 2 by 5 cubed, plus 6.5 by, I'll put in the 25 for 5 squared, and the t didn't appear there, plus 109 by 5. And type this into a calculator twice just to double check what it comes out as. The inside bracket's coming out of 561 and 2/3, or 561.67 divided by 5, 112.33 kilometers an hour for her average speed. Next part. So taking v prime t to be the derivative of v, and v double prime t to be the second derivative. V prime, when we put 1 in, is greater than 0. We've got the tangents to these curves. If v double prime 1 is less than 0. So here's 4 graphs A, B, C, and D. So close to where t is equal to 1, the graph of y is equal to v of t must look like one of these 4 graphs. So what do we say already about this graph? It's coming up. It's going through the y-axis at 109, and then it's reaching max at 1 point something, and then min at 4 point something. So we're going to have 2 turning points here. What was it again? 1.42 and 4.58. So we imagine on the x-axis 1.42 and 4.58. So what's happening here? And we exaggerate slightly and put this in as 1. The graph is coming up to reach a max, so it can't be this one. 1 is coming down. Could be this one. It's coming up to reach a max quite quickly, it looks like. This is coming down. Can't be that one. This is going up, but it looks like it reaches another. It looks like it's coming on in this direction before turning. So it looks like graph B. The reason is v prime t, if we this slope is equal to 0. Let me just do a different color. The slope just before that, the slope, the tangent to the curve at 1. Do the tangent at 1 is positive m. So v prime 1 is greater than 0. So at 1.42 m is equal to 0. So increasing function, or increasing, I might call it f of x or v of x, I'll call it function, increasing function between 1 and 1.42. And then what happens is the slope becomes decreasing on this side after between 1.42 and 4.58. So that's why v double prime t is less than 0, negative slope greater than 0, positive slope going in, negative slope after. I'll just write that, negative slope after t is equal to 1.42, or you could add in decreasing function between 1.42 and 4.58. And then if we differentiate it again, part F and G, average speed zone on the motorway. The distance from A to B is 10. Just do a little graph. A to B is 10 kilometers. Cameras record the time taken. This is the new average speed. Average speed is calculated. Work out the minimum time in minutes a driver could get to A to B while not driving faster than 100 kilometers an hour. If they do 100 kilometers in 60 minutes, 100 kilometers an hour, they would do 10 kilometers in 6 minutes at that same speed. So going a constant speed, if the speed was equal to 100 and the speed by time, we know our DST, speed by time is distance, so 100 by time would be 6 over 60. That would give the distance of 10. So these all look correct. So the minimum time would be 6 minutes. Couldn't go any quicker than that, or they would be over the average. Rohan drives from A to B. He passes the point A driving at a constant speed of 120 kilometers an hour. After 2 minutes driving at this speed, let's do a little diagram here just to see what's going on. I'll do my X and Y axis looking like this. So he's here at 120. And he goes for, let's say, 1 minute. 1 minute. That's 1 over 60. We're dealing with kilometers an hour. And he does the same again at 120. 1 minute. 1 over 60. So the area here would be 2 over 60 to get the distance traveled. This works out now, obviously you'll see in a minute why, by the height of it, which is 120. That's equal to 4 kilometers. Of course it is, because if you travel 120 an hour, you will go 2 kilometers in 1 minute. So in the 2 minutes here, he's gone 4 kilometers, which we can see. So he now needs to go 1 kilometer in the final 3 minutes. What it looks like here, I'll just divide it up here. Need it. 1 over 60. 1 over 60. Actually, we don't have the time here. Let me just check. Just rereading the question. He slows down and has constant acceleration, so we know the area of this triangle then is equal to 1 kilometer, the area of this triangle. We don't know what he slows down to. Let's have that as X. And then the time period here when he's gone, it takes, if the speed limit is 100 kilometers an hour, it's 6 minutes in total. He's already gone for 2 minutes here, so there's 4 minutes left. So we have the time here is 4 minutes. 4 over 60, which is equal to 1 over 15. So half the base, which is 1 over 15. With a perpendicular height, which is this guy. Now if X is 90, it's 30 in between, so 120 minus X by 120 minus X is equal to the 1 kilometer covered. So 120, this is 30 on the bottom, so that's 4, 120 over 30 minus X over 30 is equal to 1. So bringing X over 30 to the right to make it positive would be 4 minus 1, 3. So X is equal to 90, so that's what speed he slows down to. 20 down to 90. And the deceleration is the slope of the line. So the slope of the line is the rise minus negative slope, the rise over the run, which is the time, which is 1 over 15, which is equal to minus 450. That will be kilometers an hour. So kilometers an hour per minute. When we think about constant acceleration over 4 minutes, it slows down by 30 over 4 minutes. So that's going to be 7.5 kilometers an hour per minute, which is what they're looking for here. If you multiply 7.5 by 60, you'll get to 450 kilometers an hour.